So now that we know how to do oxidation numbers, so if an element's oxidation number is 1, then it can bond with one different element. And if an oxidation number is 2, then it can bond with 2 elements. In a formula, the positive ion is always going to come first. Okay, so now when we write our formulas, the oxidation numbers are going to switch places. So the oxidation number for one atom is going to become the subscript of the other atom. Okay, so now let's talk about ionic versus covalent. An ionic bond is a bond between a metal and a nonmetal. It's really that simple. And a covalent bond is a bond between two nonmetals. So that's how you figure it out. You see what kind of elements there are. If it's a metal and nonmetal, it's ionic. If it's two nonmetals, it's covalent. So how do we tell the difference between a metal and nonmetal? Okay, so remember, here's your stair step. Many of you have asked me what the stair step is for. Okay, so it's that dark line, and yours is more pronounced on your periodic table. Anything to the left of this is a metal. Okay. The exception to that rule is hydrogen. We know hydrogen is not a metal. Okay. Anything to the right of that is a nonmetal. These are all nonmetals over here. So left of the stair step metal, right of the stair step nonmetal, exception hydrogen. Hydrogen is also a nonmetal. So that's how you tell the difference. So now we're going to learn a shortcut to figuring out that charge that we worked so hard with yesterday. Okay, so that is important. You need to know why an oxidation number is the way it is. You need to know how to figure that out if I ask you to figure that out. But we're going to learn a shortcut. And the reason why this shortcut works is because of the oxidation numbers. Remember, the valence electrons. Remember, the group 1 has the same valence electrons. Group 2 has the same valence electrons. Group 13 has the same valence electrons. So if elements have the same valence electrons, they're going to have the same charge. So if group 1 all has one valence electron, they're going to lose it. They're all going to be +1. If group 2 all has two valence electrons, they're going to lose them. They're going to have +2. Group 13, if they all have 3 valence electrons, they're going to lose them. They're going to be +3. Group 14 is all going to have 4, so it's going to be plus or minus 4. Group 15 is going to have 5, and so that's going to be -3. It's going to gain 3 electrons. Group 16 is going to be -2. It's going to gain 2 electrons. Okay, so now that we learned the shortcut to determining the oxidation number, we can quickly go through these examples and figure out the oxidation numbers. And then we can practice our formula and then determine whether they're ionic or covalent. Okay, so aluminum's oxidation number. Okay, aluminum is in group 13, so its oxidation number is +3. Fluorine's oxidation number, it's in group 17 right here, so its oxidation number is -1. Okay, so that part's easy. Now writing the formula. Okay, things to remember. The positive ion always comes first, so we have to write aluminum first. Now, how many aluminums you have? You have to look at the other oxidation number. You have to look at the oxidation number for fluorine. So this tells you how many aluminums you have. Now, it's not negative because the subscript tells you how many there are. Remember our counting atoms? So there's just 1 right here. Now, we don't have to put a 1, right? It's just, we know it's 1. So then we write the fluorine, the F, and then we're going to write the oxidation number for aluminum. So 3. So AlF3. That's the formula for when aluminum and fluorine combine. So we write positive ion first. The subscript would be the charge of fluorine. the negative ion second, the charge of the positive one. Ionic or covalent. So do we have a metal here? Well, aluminum is on the left side of your zigzag line, so that is a metal, so this would be ionic. Okay. Beryllium. Beryllium's right here in group 2, so that's +2 charge. Oxygen's right here in group 16, so a -2 charge. That's a typo. This should be -2. Okay. This is going to be -2, you guys. Okay. So, writing the formula. Positive ion comes first. Now, these two have the exact same oxidation number. So, if you have the exact same oxidation number, you're going to reduce the charge. So it'll be like just reducing just like a fraction. Like if you had 2/2, you would reduce that to 1. So here it would be BeO. Okay. Is it ionic or covalent? Well, beryllium is right here. It's on the left side of the zigzaggy line, so it is going to be ionic. Oxygen. Oxygen is right here. It's in group 16. It's -2. Hydrogen right here. Group 1 +1. Okay. Positive ion always comes first. Notice I tricked you. Put the positive ion second. So my hydrogen has to come first. How many? I look right here. 2. Then I put my O. And then how many? I look right here. 1. That's water. We just made the formula for water. And is this ionic or covalent? So do we have 2 metals or 2 nonmetals? Now, hydrogen is on the left side of my zigzaggy line, but remember that's the exception. Hydrogen is a nonmetal, so this one is covalent. Lithium. Lithium is right here, group 1, so +1. Nitrogen, right here, group 15, -3. Positive ion comes first. How many? Is this many right here? 3. Nitrogen comes second, and then how many? 1. So I don't have to write it. Okay, so now you're going to have some practice. So go ahead and take a couple minutes and work on that. Okay, let's see how you're doing. Okay, so barium. Barium is down in group 2. It's down here. So that's a +2 charge. Chlorine is down here in group 17. So that is a -1 charge. Okay, so your positive ion comes first. It's Ba. This tells you how many right here. So 1. Then we have our Cl, and this tells you how many. You have 2. So you have to figure out, do you have a metal there? So zigzag lines right here. And barium is on the left side, so it is ionic. Magnesium. Magnesium is right here in group 2. So it's +2. Bromine's down here in your group 17, so it's -1. So magnesium is +1. You have 1. Bromine is your -1. And you have 2 again. So, is magnesium a metal? So yeah, magnesium's right here on the left side, so that is ionic. Oxygen's right here. It's in group 16, so -2. Potassium is down here in the first column, so it's +1. Positive ion comes first, so I tricked you again. Potassium first. This is how many. I've got 2. Then my negative one, so oxygen comes next. And then this is how many, so 1. So is potassium a metal? Yeah. It's over here, so ionic. Aluminum, it's group 13 again. We had that one. It's +3. Phosphorus is in this column here. It is -3. So remember what happened when we had the same ones? They canceled out. So we'll have AlP. Okay? And aluminum's a metal again, so that's ionic.